Alright, so our topic for tonight is going to be databases. We're going to look in the theory textbook, chapters 8 and 9. We'll see what time allows. Otherwise, and then we'll go to our practical textbook also, chapter 8. And then as we go through that, I will maybe just on task 3 of your PET, it also refers to your database design. So I'll see how I can incorporate those 3 pieces all in tonight's lesson. So practically, we're not going to do any databases today. That we'll do next time. Main thing for tonight is so that we understand where does databases come from, what are they there for, what is the purpose of it, and so forth and so forth and so forth. All right, so okay, so my first question to all of you or any one of you. No, I'm going to tell you and I'm going to ask. So what we've got if we look at the Microsoft Office package or any Office suite, as they call it, you get a variety of programs. The first one is like word processing, like Microsoft Word. That is to create documents, type large documents and reports, and just typing a lot of stuff. The next package you'll get inside there would be a spreadsheet, like Microsoft Excel. That package is created to work with numbers, to analyze them, create charts, and do basically statistics. What you do in maths, you can do there, getting averages and totals, and then do graphs to represent data in a meaningful manner. Then one of the other applications we get is presentation programs like Microsoft PowerPoint, and that is a program that allows you to present data in a nice way to clients. So just put it in a nice way to do presentations. Then the fourth package that's generally part of an Office suite is a database. Do any of you know, like, what is the purpose of a database? Why do we have it? What does it do now? Like if Word stood for typing and Excel is for numbers and PowerPoint is for slides, what is a database for, or Microsoft Access? What is the purpose? So the question is a database. What is our purpose for a database program? Why do we have databases? All right, so yeah, you basically refer to the right part where the thing for a database is to store data. So that's the idea, but in a meaningful and organized manner. So a database is created to just store large amount of data, but in an organized manner so that when we want to extract data, we can get specific things from there. So just if we look at your school for argument's sake, what type of data will be stored in the database of a school? Okay, so learner data, yes. Yes, so that sort of goes with learner data. So learners and all the information, their ID numbers and names, and so everything to do with learners. What else do you think? Yes, so staff. So it would be teachers and administration and ground staff. All their data needs to be stored. Can someone think of something else that would be stored in a database? Okay, yes. All right, yeah. So we'll have a database for all the textbooks we've got. And then one other one that could be is maybe like assets. So it could be all vehicles could be stored maybe, and you could have maybe even not so much desks and chairs, but also probably some of that. So all assets. So if you look at these things, so we're basically storing information about an object. So it's either of students or staff or cars or textbooks. So generally it's like storing information about a specific topic in there. So how databases work, you'll have one program, and that's our first part that we'll start with. So that's database software. So you'll see the word they use is DBMS. It's a database management software. So for you guys, for us for this year, we're using Microsoft Access. So Microsoft Access is DBMS software. Now DBMS software, as the word says, database management software, is just software that allows us to work with a database. So we can create databases, we can create tables, we can add new data to databases, we can delete information, we can retrieve information, we can make data available to users, make data available to applications, create, manage, monitor users using the database. So DBMS software allows us to basically manage our database, adding, removing, changing, seeing who's using it, whatever we can do. That's what DBMS software does. Now, the one we're working, as I said, is Microsoft Access. You do get quite a few others. You get Microsoft SQL Server, you get Oracle, we're using Access, Blackfish, PostgreSQL, MySQL. So all these ones. MySQL is generally quite used a lot because it's open source. Open source tells us what again? Yes, source and can be modified. Like what is so those two are big advantages, but there's a bigger advantage. It's free. Yes. So open source software, source code is free and you can look at it and you can change it. Main thing, yeah, it's free. We don't need to pay for it, and everybody works together on it. So it's like a community project. But for us, we're using Access. Oracle is also quite widely used in companies, but this one is you pay for it as well. So that's not a free one. Um, then you'll see. So the advantages of using database management software, you can share data, data independence, we'll come back to that now, better data integrity. Um, what does integrity mean? What do you think that word integrity, what does it tell us if we say better data integrity? Mm, so it does that, but that's not what integrity refers to, though. Yes, accuracy and I want to say like believability, if you could use that as a word. So with integrity means if the data that's there that you can trust that it is still the original data type of thing. So that somebody didn't go and tamper with the data later on and stuff like that. So DBMS software, because it can manage who and when the database gets accessed, you can sort of have some limitations on that to make sure that the data doesn't get edited by the wrong person. And then controlled redundancy. What does redundancy mean? Yes. So controlled redundancy. So redundancy generally is bad. We don't want redundancy. You don't want to store the same data more than once, because then you're just making it very the database big. Because if you store, let's say we stored your data when you were in grade 8, and then when you went to grade 9, we just added that data. When you went to grade 10, we just added it. Now that you're in grade 11, in our database, your specific details are there 4 times. That is bad redundancy, because now we're duplicating the same person's information, even though the other stuff is old and we don't use it anymore. But controlled redundancy, I'm saying that we don't repeat like unnecessarily. But when would we want to repeat data that is necessary? Or give me an example of data that will be repeated, but that's necessary. So in a database, there are some data that we're going to repeat. That's why it says controlled redundancy. There is redundancy in databases. But now I want from you guys, if you can think of an example of why would we ever want redundancy in a database? What example of data will be repeated? Alright, yeah. So why would your address be repeated? Yeah, but you see, that's one of the things we wouldn't want. We don't want to store your information more than once. So if so, like let's say like normally your information, your school database should only appear once. If it's there more than once, they've got bad redundancy. Yes. Yeah. Yes. So you could have redundancy like that. And other ones are like ages and grades. I mean, if you want to store the grades, we need to repeat grade 11 for all the grade 11s. So grade 11 gets repeated, but it gets repeated by different people. And as you said, there could be people with the same name. So then you do want to repeat that name because it refers to a different object. So the key thing with this redundancy is we don't want to store the information of one object more than once. So, like Mwandle said with her address, we don't want to store her address more than once, but if there's information about Richards Bay, that we only want to store once as well. But Richards Bay will appear more than once because there will be quite a few students from Richards Bay. So some redundancy is needed, but we want to try and reduce it as far as possible though. Then data consistency, just so that the data looks the same the whole time. Data security, so that goes with our integrity part to make sure data is secure. Faster application development. So you'll see if any of you take CAT, you learn how to use Access actually, and you'll see it's quite easy and fast to create reports and forms. When we're going to create it now in Java and in Delphi, it actually takes longer to create reports and forms. So using DBMS software, it allows us to do that faster. Concurrency control, I've got no idea what that is. And then recovery and backup. So generally DBMS software has got the backups, so that if something goes wrong, you can recover from something you saved. So these are advantages. Do you need to know them all? No. Do you need to know like 3 of them? Yes. Generally, they will ask you, give me like some advantages of DBMS software. then you need to list some of them. Now, databases, there's like different categories of databases, if I can say it like that. So firstly, you can choose between a desktop database or a server database. Desktop one is like on the computer itself. Let's say that database is in the IT lab on one of those computers. And then it means the person that works on that computer has got access to it. However, a server database is a database that's stored on a server. And then anybody with network access can actually connect to the server and work on that database. So there's pros and cons again, both ways. So you'll see there, they say determined by the following two factors. So the first one is the size. How much data will you store? Obviously, the more data you want to store in there, most probably it will move over to a server. And then the key one actually is the accessibility. If you want multiple people to work or to use the data on that database, then you'll put it on a server. But if it's just one person at a time, then you might consider desktop. So it depends on that generally, which one you'll want to use. So you'll see that it's basically refers to a single user database, which is on a desktop. All right, then I talk a bit about that. There is a thing called a distributed database. So a distributed database generally works, it runs on servers, but generally multiple servers. So as the word says, distributed database, so the complete database isn't stored in one location. You actually have the database that's being broken up into smaller pieces and shared in or stored in different locations. So you'll see that it can be stored locally at your organization's premises or anywhere in the cloud. All the resources that's located to this database are being shared amongst all the users that are connected to it at any instance. It supports multiple users. Let me just see. So you wouldn't necessarily know. A distributed database, the key thing there is this part here. Databases that are not stored and run from a single computer. So I would say those companies, I would say you are correct in that it is a distributed database, but you can't just like definitely say it by just something you see like that. It's more with the people that created it. If they created it and stored it on multiple servers, then it is. Otherwise, not. Like, it could have been just a normal one as well, just a server one. Yes, but what I would want to say, maybe like if you go with Facebook that uses, if they were, or the database it uses, most probably it is a distributed database, and how that would work is it would most probably have a server. Let's say, argument's sake, it will have a server in every country, and then so in South Africa, let's say in Johannesburg, there's a server that manages Facebook for South Africa. Now, how that works is everybody in South Africa that creates a Facebook account, it will be stored on that database. And everybody in China that creates a Facebook account will be stored in that, in the China server. And everybody in Russia that creates one will be a Russian server. And everything in America will be on an American server. So when you connect and you basically look at people that's around, you're connecting to the South African server and you're just looking on everything that's there. Does that mean you don't have access to the others? No, you do have access. You could still just Facebook somebody from America. And it seems like both of you are working on the same server or the same database. But not. So that would be a distributed database. So there's all these servers. The data is saved in different places. Like South African data is here, and American data is there. But using the internet, it basically links the two servers and the two databases so that it virtually looks like one, but then physically it's actually on two separate locations. And that's how the distributed database works. So just sort of, if you understand that, you can think of advantages around that. I mean, what would you say? What are advantages or disadvantages of having a database like that? Yeah, so you can go both routes. A person would have gone the advantage part for that, in that if you want to connect with people or data that is closer to you, it is actually much faster. Because generally, I mean, if somebody in South Africa goes to Facebook, you agree, most people connect with people in South Africa. So for most people, having the server in South Africa is better, because what is the alternative? Alternative meant the server would just be in America. So then, even if we wanted to connect to somebody in South Africa, it would also be very slow. So I would rather go the opposite of saying slow. I would rather look at the positive of it, saying yes, yes. But then a negative of it is your server is not in one place, so it's scattered all over. So if something happens to, so now you've, instead of having one um, computer or one place to protect, you need to protect more than one place, more than one building, more than one server from hackers. So you are now a little bit, security is a bit more difficult to manage. But again, if something happens to the South African server, then all the other data is still fine. You don't lose all of your data at one time. And most probably, they would have created backups in different locations. So the South Africans' data would have been backed up to America, and America's data would be backed up to China, and China would back up to Russia. So most probably that could be an advantage also, again, that if you lose one location, all data isn't lost. So I want to say, if you get a question like that, try to, if you understand the concept, then just think of alternatives. Why do you think it would be a good or a bad thing? But yes, so distributed databases, that's why they say are more reliable, since it can continue as long as one of the databases stays active. All right, and there they talk a little bit about those things. Nice, interesting reading that you can do for yourself if you want to. Database careers, I'm not going to spend actually any time on this. You can go through this list. Is it not important? Unfortunately, it is actually important. They, up until grade 12, they love to just ask you like one random question. In a grade 12 final paper, they will get a question saying, oh, database analyst, what does he do? And then you sort of need to have an idea of what he does. So, but this is just, how to say, study work. You must just see what these people and what they sort of do. Do you need to know all the bullets? No, not at all. Just have like a brief understanding, or a difference, know the sort of difference between them. If I can quickly go through it, the database administrator is basically the one that works with the database. The database is there and we're working with it. A database programmer, his main purpose is creating the database properly. So he's sort of like, okay, not this starter, this analyst guy would be actually before. So your database analyst is the one that will start the whole process. So you'll go to a company and decide what the company needs. The programmer will then go create that database for them, and the administrator would manage the database after it's created. So like for the rest of the years. So creating the database is basically these two. Once it's created, the administrator takes over and he just monitors and maintains the database. And your project manager sort of looks at these two while they're creating the database. Just that they keep on track with deadlines and that it's created on time and does all the specifications it should do and so forth. So monitoring and managing the project that these two are creating. But yeah, study work. So unfortunately, yes, you do need to know it. You will get questions about it. So yeah, it is one of those things. All right, and then we're going on. Next one, database design. So um, maybe before I start going too much in there. So a database. Tell me, is there any one of you that has never worked with Access before? Is it open? All right. Okay, so let me quickly give you a quick run through. So, all right, important things to know. When you create a database, I'm just going to create a blank one. All right, so each company, so this is important for your pet as well. So you're going to use this in your pet. Um, you need to create a database. Now, each company will only have one database. So in the past, some people or schools that didn't have a nice teacher guiding them, they would have created multiple databases. And that's wrong. Even like Epagini High School or Facebook, they would have one database. The difference is inside a database, you can create multiple tables. So there's 4 key elements in a database. The first one is a table. Now, a table is the most important part of a database. That's where the data actually gets stored. So if we take our example of the school, you would have a table for staff, and you'll have a table for students, and you'll have a table for textbooks, and you'll have a table for assets. So each of those tables would store all of the information. So if we take the student one, every single student would be stored into that database, into that one table. So for like the school, you would have 4 tables and all the information goes in there. So the table component of a database is where all data is stored. Then the next thing you get is queries. Now what a query does, a query gives you a part of a table. So we'll use this in our programs. We're also going to use this. We're going to work with this with SQLs. So I think some of you would know about SQLs. If you don't know yet, we're going to get to that. But it's a language to work with databases. Oh yes, queries. So because what could be like, remember I just told you now, we'll have a table for, all right, so like I said, we might have a table for uh, students, but now it will be all students. So like in Epagini High School, there's 1,350 students. So all of them would be here, all 1,350, all of their names, surname, ages, the parents' telephone number, addresses, all that data would be here. So the table actually looks crazy because there's just so many students. And I imagine Mr. Zwane just wants to know who is the IT students. Now they can't go through that every single one to check who takes IT. That would just be crazy long. So that's where queries come in. We can create queries that could extract only certain data for us. So we can say, only show me the IT students, or only show me the grade 10s, or only show me the boys in grade 12, or only show me the grade 11 IT students that already had 5 detentions. So that you can do with this queries. So with this one, you can extract some information according to certain criteria from the table. You can also edit with queries. You can add records. You can remove records. So add people, remove people, and change some information inside of that. So all of that you can do with queries. You're sort of adjusting inside there. A table, maybe to just go a little bit deeper into a table has got records, which is rows, and it's got fields, which are columns. So records has to do with one object. So like each one of you would be a record in your school's database. One row would have your name, your surname, your age, your all that stuff. Fields are something like ID number, first name, surname, address, telephone number. So a field sort of tells you what type of data will you store in that table. And then record is each person or each object, the information that is stored there. Other two components in a database that we're not going to use. The one is a form. That is a nice visual representation to enter data into a table. Now we're going to do that in Delphi. We're going to create our own forms in Delphi code to enter data into our tables. And the other one is reports. And reports is to extract data out of a table to put it in a nice format. So that we're also not going to use. We're going to create our own report format with Delphi and our own GUIs. We're going to create our own forms and reports to display the information nicely and to input information into or edit in our tables. So we're going to use our database, only the table part, to just store all the data. We're not actually going to do these other three inside our DBMS, inside Access. We're going to do these three in our Delphi program. We're going to create our own queries and our own forms and our own reports. So that's for your pet. All right, then, yes, talk to me. When you're thinking of your pet and the tables you're going to use, do a little bit of research though, in the sense that if you think textbooks, then like you said, the date and the name of the book and then the student, there's actually much more to each textbook. Each textbook could have an ISBN number. That is very important. You could even maybe include the supplier where it gets bought from. Maybe that particular textbook, you could have a want to say damage rating or quality rating, or like because some of the textbooks are a little bit damaged, so then you could have that where you give them a rating is a 3 out of 10 that textbook, so you can keep track of that. So once you start thinking a bit creatively, there are more than one thing that you can actually store about a textbook. The subject that it's for, the grade that it's for. So all that information could be stored for each of the textbooks. And then, yeah, for students, there's a lot. There's really a lot. I would, however, also for your pet, not suggest that you save everything of students. Choose some. ID number, I think, is important. Name, surname is important. Grade is important. Date of birth is important. And then from there, I think you can go a bit down. I don't think all of the parents' details should be stored there and stuff like that. So then you could have a little bit less. But around about that, I would say a good number is to have about 5 fields for each table. A little bit more is fine, a little bit less is okay also if you can't think of something else. But try to go for at least 5 of each. And I would say once you go more than 8, it's a bit tough. I wouldn't go. So between 5 and 8 is a good number for the amount of fields you should have in a table. Okay. So yes, so you need 2 tables, and then let's say within you need that. So with each of these fields, remember fields is like name, surname, age, something we're going to store of each of them. once you do that, let me just see here. You can actually, like when you're in Access, you can go to Design View. And then this one, you'll see there's all the field names that you can put the fields in. So creating this one, that's what we'll do next time. In our next lesson, I will guide you to create your own database for your pet. What I want you to do, however, at this stage is just to start thinking. Think of your topic. Hopefully at this stage, all of you've got a topic that my database or my pet's going to be on this topic. And then you need to think of the 2 tables that you'll need. Please just remember or keep in mind, something like I said now, we'll only have a staff table. You won't have an admin staff and a teaching staff. You wouldn't make that 2 separate tables. You'd keep it one because information you want to store about them is exactly the same. You might just have one field saying which section or which area of expertise, and then it can say either admin or ground or education. So, but the rest of the data is the same. So all that should actually be in one. The same with textbooks. You wouldn't create a table for math textbooks and another table for physics textbooks. You'll have one table for textbooks and maybe have a field for like which subject it applies to, and then just maths and physics there. So keep that in mind and then think of 2 sections of information that you would want to gather information on for your pet. Then once you've got the 2 tables, think of the fields you'll have in them, and each field should have a data type. Like if you go name, then you must choose a data type. So generally text is one, a number, date and time for like date of birth, yes and no is Boolean, that's for like true and false. So generally you'll choose between those ones, either Boolean, date and time, text, or number. So you'll just tell me which fields you need and then what data type they will be. These other ones you won't use. People that study cat, they'll use these other ones to do different things. For us, we're just using this to store, and our Delphi program will actually do most of the other options here. If we wanted something else, if we wanted a picture stored, or if we wanted a hyperlink, or if we wanted like a combo box, then our Delphi program would do that for us. So for now, you basically choose between text, number, date and time, and yes and no. That's sort of your options to choose from. And then you create your database accordingly, or the tables in your database. You don't, as I said, you don't need to create it now, but you can just think, maybe just put it on paper for me. So that's basically what we're doing here. So this next chapter is on database design. So you'll see what they say. What we need to do is decide which data to record. So that's what I asked you. Decide which 2 tables you want to create. Decide how to group the data. Decide which fields to use in your tables. Deciding what type of valuable information it is, so the data type of that. And then decide how to maintain. So what I mean there is you need to decide what will you do with each of these tables. Would you want your program to be able to add new records? Do you want it to be able to remove records? Do you want to be able to change some of the values in the records? So that's basically what you also do there. Just deciding what will be in your database, what's the data types, and then how will you be able to interact with it. So at this stage, you've got a topic and you've got 2 types of users. So maybe in a school, you'd have the principal and you'll have maybe just an educator, or maybe a student for that matter. Then now you'll see, okay, let's go to the teacher one. So you've got a principal and you've got an educator, and then the database. So maybe in the database, the school decided they're going to have the staff details and they're going to have student details. So what that maintain part will be, it will actually differ for the 2 users, because now the principal. You would want the principal should be able to add staff members, remove staff members, and change the information of staff members. And the principal is also supposed to do the same things with students. But then staff members, they must also be able to do that with students, add, remove, change. But they should not be able to do that with other staff members. You don't want staff to be able to remove other staff or add new staff so that somebody can just decide, I want to hire somebody without even the principal's knowledge. So that's how the two users would differ. So between your two tables, those two users, both of them will most probably have access to both tables. It doesn't need to be. Maybe you can have the one hidden. But most of the time, both users will be able to see both tables, but they won't be able to do the same things with them. So maybe the staff can only view the other staff, but they can't change anything. But the principal can. Maybe something like that. Okay. All right. So here they also talk a little about databases. Here's a school library. They talk a bit about it. Then there's activity, nice activity to keep you busy. All this. All right, so characteristics of quality data. So hopefully, I think in the past somewhere you did learn the difference between data and information. So data is raw, unprocessed facts, while information is processed data, basically. So the data is raw material, information that needs to be, that when data is organized and presented by someone. For example, I take pictures and they talk about it. Knowledge is information read, heard, seen, or understood. Let's just see what this picture shows us. So then data can become information, or data can become knowledge when you learn from it. And that is used for decisions then. All right. So these table of characteristics of quality data, this is very important. Up until grade 12, they love asking this question. They will ask you quite a few of these characteristics, or they could sometimes give you some of them and ask to explain. So quality data, the first thing is it needs to be accurate, so error-free. We cannot store information in our database that has got errors. That just sort of defeats the object, storing information that's wrong. Correctness. So inaccurate data is the downfall of a database. You might not as well have any database because it's going to lead to the wrong decisions being made. So it must be correct. Current means it must be new, not old. If it's old news, if it's old data, like if it's data of 10 years ago, it's not going to help us now. So current means it should be recent information that's stored there. Data should be complete, meaning if you've got a staff list, if you've only got some staff members there, then it's not going to help. You need to have all staff members and you need to have all information of it. It doesn't help if you've got some staff members where there's just a name and then you don't know telephone numbers or anything like that. So you do need a complete database to work. It needs to be relevant. I mean, storing information, this is also, it depends on your scenario, but I mean like in the school database, if the school database stores information about students in America in the EHS database, that really doesn't help at all. So it needs to be relevant to the school, the information you store in the database, something they'll use. And it needs to be consistent. The data in your database should be consistent, which means the data in one part of your database should not contradict or differ from the data in another part of your database. You should not have, when you're storing, remember we said there will be some redundancy, but now your redundancy can't, where it gets duplicated, then suddenly it goes wrong. All right, so nearly done. just finalize this one. So validation of data. Let me just too fast. Or you know what? I'm gonna stop here, I think.